Hey, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. Today we have a Sansui A80 integrated DC servo amplifier. Now this is the first in a pair of Sansui amplifiers that was brought to me by a client, and we're going to go through this one. This one not so much. He told me this one is going to be gifted to someone else, so he just wants it working fine, working good. He doesn't want a full restoration on it. He doesn't want to dump a bunch of money into this. So he just wants to get it going good and working properly. And I believe he told me it has a problem. The power switch is failed in this, like the other A60 I did had a failed power switch. I guess it's pretty common for these garbage switches they put in here to fail. So we're going to deal with that. Now, this is the big brother to the A60. If you go back, I'll put a little link up above for I made a couple of videos on the A60, and then I turned around and sold it, and it was a good sounding amplifier. It sounded great. I really liked it, but it did have its flaws. It was yeah, well, we won't go there. But let's focus on this one. The A80. It has some nice features. It's got the dual power meters, and it has a LED, 5 LED bar graph here. I think it's a sum of both channels, or an average of both channels, I don't know. Volume, we got 2 tape inputs, a phono, which is selectable between moving magnet, moving coil, tuner auxiliary input, and then we have our tape 2 up front. That's kind of a nice feature to have up front, and they got a cover for it. And then you have your record out selector, so you can decide what you're recording from, decide what you're listening to, balance, muting, 20 dB muting, this weird loudness potentiometer, like they have a volume and then they have a loudness. That's odd. High and low filters, treble and bass. Back of the unit, we got our inputs, our 3 inputs, phono, tuner, auxiliary, and our 2 tape loops. I guess, I'm not sure, but I'm thinking the front is connected through to this directly, so I might have to keep that in mind. So you wouldn't hook a tape deck in the front and the back. It probably wouldn't work. 2 speaker outputs and 2 switched and unswitched courtesy outlet. Alright, so it's wired in a pair of speakers, and I got a 440 tone going in. Let's try this out. Hang on a second here. Helps if we plug it in, doesn't it? Okay, going live. Instant on. I don't think that's correct. Both channels are working good. A little bit scratchy. Yeah, just dirty, scratchy pots. I can barely see this light. Can you see that? See how dim that is? Those old LEDs, they go so dim. Dirty switch, that's for sure. Let me try the auxiliary, see if it's dirty like that. Yeah, same thing. I have to clean that switch near the phono stage. Our moving coil now. Moving magnet. not bad. Both channels. Aside from the dirty pot, I don't think we have any noisy transistors. Okay. The lamps are out for sure. I think he said the power button wasn't working. It was arcing or something. Yeah, that's an arcing sound. 16 watts. There. Yeah, there's something with that. I think that's the power switch. But usually you can hear it arcing. I don't hear any arcing noise. It's silent. The silent killer. Alright, it was looking kind of grungy, so I took a rag and some glass cleaner and just wiped the top. And that's how dirty it was. I did have the lid off, and I did blow the dust out of it. It was quite a lot of dust in here, and it's a lot cleaner now. I'm glad I did it because a bunch of dead flies came out too. Now my client, I apparently bought this at a garage sale or estate sale, and he wants it refurbed before it gets passed on. So I don't know where it came from, but yeah, it was a good thing I blew it out. I hate dead bugs and stuff in things like this. It just drives me nuts. But here's a good look at inside. Get some light on it maybe. Got a big chunky power transformer in the top corner there. And we have a single, I got it unplugged. I got a single 5 amp fuse here. A little small power supply circuit here. A couple of 6800 microfarad at 63 volt caps. And a fairly adequate heat sink. We've got our output devices hidden under a spring clamp, and everything looks pretty good. The meters are enclosed in a box. I have to go after the lamp in there, and everything looks pretty original, untouched. Okay, off with the bottom. It's dusty, and it looks all original. I don't think anybody's worked on this before. Everything's original. Okay, it's a good start. Okay, first up, the power switch. So let's deal with that. So this is what really annoys me or pisses me off with these Sansui receivers, amplifiers, any of their gear from this era. I just pulled this board out, and here's the power switch. And look what I see. I'll point it out to you here. You got your mains wiring. This white wire here is your mains wiring, and where's the other one? It's buried in these other wires. I can't even see it. This other white wire. But look what's tangled in between all these mains wiring is we have other wires that go to the speaker, headphone jack. So this is unacceptable. This is absolutely unacceptable to have a manufacturer put mains wiring on a switch like this and then have it surrounded by all these other wires and conductors. What happens if for whatever reason the insulation gets burned through because the switch is arcing inside, it's getting hot, and then burns through the insulation on one of these others? You can get electrocuted. I got a real big problem with Sansui for doing this. So my solution is remove this switch off the board completely, because I don't want to see mains wiring on this switch either. They got the capacitor on the back here. So I'm going to install this switch. It's a fully rated switch, and it's good for 5 amps, which is adequate for this. And I'm going to install this instead and have the mains wiring go here. And the capacitor, they don't even have an X-rated capacitor on here. I think it's just a it's a 10 nanofarad 125 volts AC. I don't think it's X-rated or Y-rated. So we'll do something about this capacitor too. We'll put it across the terminals. We'll get rid of this completely. Here's a look at this is the voltage across the AC switch. What is it measuring right now? It's measuring on the 300 volt scale. It's up around 125. That's what this shows. So let's turn on the power here and we'll see what kind of voltage drop we have across that switch. Oh, look at that. 100 volt scale, we got 60 volt drop across that switch at 300 milliamps. That's a lot of power that's being dissipated by those contacts, and it's just heating up. Try that again. And then it clicks in and behaves. Burn, baby, burn. That can go on forever. That could burn your house down, that nonsense. Okay. Let's replace the switch. Okay, I just took the side panel off here just to show you the switch install. So the switch has been removed from this PCB board. So the mains voltage has completely been removed from here and is no longer an issue for me. On this side, the switch is floating over the board, and just enough room in the front. I added an extra screw and a washer to secure the other ear of the switch, and it's very very secure. Now if you just do it with one, the switch will flex and bend and you can snap either the steel mount, or the switch will go loose, or you break your wires, but you want to have that switch secure. So I pulled out the filter caps there's some green corrosion here on some of these jumper wires. I want to clean this off. Can't get in there very good, so I pulled the caps out, clean off all that stuff. But I discovered something else about these caps. So these are 6800 at 63 volts, both of them, and they feel kind of light. Let's see what they measure out at. And you can see right there, that is only 2600 microfarad, not 68. Down quite a bit in value. Let's try the other one. Same thing. 28. So we're going to replace these. I have a pair of 8200 at 63 volts. The originals are, what are these? These are 30 millimeter diameter, and these replacements are 35 millimeter. Should be able to squeak them onto the board. There should be enough room there, but we'll see. I'm getting low on actually capacitors. Put another order in because really have none to select from. I only have the 8200s. I'd like to get some 10,000s, but we'll do that. I have the new caps installed there. I've gone through and checked quite a few caps. Some of them I've pulled out and tested, and they're all fine. They're not 100%, like they do have higher ESR than a brand new cap, but they are ready to go back in. So what I have to do now is I have switches, pots cleaned here. I have to clean the bass treble controls down under here. They're really difficult to get to, so I'm going to have to either remove the front panel or try some trickery to get these two. Alright, so here's an update on what I'm doing with the lamps. So these two lamps are 8 volt incandescent, and they say on here 8 volt, 0.3 amp on both of them. I don't know if you can see that. 0.3 amp. So 300 milliamps. So these were wired in series, and these white wires here, 4 white wires, are for the lamps. They came, this blue winding coming off the transformer, this is 16 volts AC, and the two lamps are wired in series across here. They had a middle post, and you can see the two lamp wires are connected to the middle post. Middle post is not connected to anything, it's just there for a connection. So I remove this side of the lamp. This side stays connected because this side is a ground connection. This little power supply here is actually, it's a single wave rectification, passes through a resistor, dropping resistor, looks like a 1200 ohm, and then it goes through a cap to filter it. And that supplies power on this brown wire. This goes to the front panel, which supplies power for the LEDs that's lit up when you turn the function switch. So my plan is to rob power from this little power supply. I moved the white wire from here to here, okay, and that leaves, there's this resistor that's not populated at the factory, and I can drop a resistor in here, a dropping resistor of probably 2K. I don't know, I'm not sure yet, because this resistor here also drops current. What I've done is I just cut the bulbs off and soldered on a white LED, and that's going to be our light source. Let me just shrink these. Okay, so this, pull this back up, and that's going to be my light source. Now this fits up inside this shroud like so. So what I plan on doing is just have the LED shine straight up and reflect off this white surface, and then it should provide a nice flood of light for behind the meter. So that's what that's going to look like. So what I have to do right now is I need to solder on the other LED, and then we can test. I still need to figure out a value for this resistor. I think I calculated, if this was not dropping anything, this is about 2600 ohms, but I might have to put in, depending on the brightness too, right? If the LEDs aren't bright enough, I'll turn that resistor down in value and turn up the current, and the lights get brighter. Alright, so I got the other bulb in, or the other LED in, and I tacked in a 2200 ohm resistor just as a temporary test here. Let's try this out. Okay, here's a look at the little power supply that they had built here. This is Sansui's power supply. This is your AC 16 volts, and it goes here, and they had the two lamps wired in series. Here's one white wire for the lamp, and then the two join in the center, and then the third one here I removed and moved it over here. So this little power supply here supplies 1.9 volts for the LEDs on the input selector. That's all its job does, is it takes the 16 volts and rectifies it. There was a dropping resistor here of 2.2K, 2.7K I think, I can't remember. And then there's a filter cap, and then on the output there was 1.9 volts for the LEDs. So I modified it, I removed this resistor and jumpered it, so then you have the diode go straight to the capacitor, which is 100 microfarad at 25 volts. And then I installed another dropping resistor. This is a 2.2K, and this is for the meter lamps, the meter LEDs. And this white wire now goes out to the meter LEDs. And I added another dropping resistor here for the function switch LEDs, which is, I think this is another 2.2K, I think. Can't remember now. And then this wire goes up. This is 1.9 volts coming off here after it goes through this resistor. So everything's working normal, and it all functions. Alright, so I got it all assembled and it's ready. This is what it's going to look like. And we can try it out. If I can get... You got to be very careful of this. Don't plug it when it's not plugged in. This fuse here is at line voltage, and so are these three terminals. That's why you got to make sure you unplug it when you're working on this board. So I'm just going to slip this into place here. And approximately right there, that's where our shroud goes. Okay. Let's turn lights off. And we'll see how this lights up. Should be ample. I think it's going to work out good. The lettering is backlit, and the meters are lit well. If you can see that, let me turn all the lights off, and then you'll see. There it is. So, lighting's done. So, let's move on. Alright, so there's some confusion here with regards to the bias adjustment. So here we have the service manual adjustments. This is for the A80 down here, bias current adjustment. And it's asking for voltage across R87, 1.5 millivolts. Voltage across R88, 1.5 millivolts. All sounds legit, right? Okay, let's look at this then. So this one's for the A80, and I'll scroll down and we can see what it says here for bias adjustments, and it shows us connecting the voltmeter across R87 across both emitter resistors, and R88 across both emitter resistors. Okay, now Sansui, I'm not impressed that they call R87 for this dual element emitter resistor, because there's actually two resistors here, not one, and they call it one resistor as R87 and R88, which is technically incorrect. They should be listed as two separate resistors. So that's where they're showing us to take the measurements. Okay, let's now look at this. Now here's the schematic for the A80, as you can see here in the top left corner, and this should be the correct one for our amplifier. So if I go down and scroll across to the power amplifiers, I don't know if you can see this, it's pretty grainy and messed up. So let's see if we can show you this. So right here they're showing, let me get that out of the way. This is showing this is R87, okay? And then they have test point 1, test point 3 on the outside of these 2.33 ohm resistors. These are emitter resistors. That's where they want us to take our reading. If I go down and look at the next channel, it shows the same thing. This is R88 here, and it shows the test point, and then it shows taking a DC voltage of 3.3 millivolts across both resistors. So which is it? Is it 1.5 millivolts or is it 3.3 millivolts? I kind of think it's a screw up here, and it's not sure. So I have a feeling I'm just going to adjust it to 3.3 millivolts across both resistors, and then we're going to call it a day. I don't think there's that much difference between the two measurements. A little higher bias will just mean a little higher current consumption and a little more wattage consumption. So there it is in the manual. So for doing bias test, I tacked on a couple wires across the emitter resistors here and here, just because there is really no room to get my test leads in and clip them on the resistor from the top of the board. And it's really crowded in here, and there's no room to stick my hand. This was the easier solution. So I'm going to turn this on, and we are going to let this warm up for about 5 minutes, and then we're going to come back and do our bias tests, and it looks like we're sitting around 2.4 millivolts right now. But we'll let this warm up and stabilize, and then we'll come back. Alright, we're about the 5-10 minute mark here. I wasn't really paying attention, but it's been in for quite a while, and we've climbed up to about 7.5 millivolts and still climbing. So let's turn this down a little bit. Let's get a little trim pot here. Let's turn this down to about 3.3. Oh, before I start, okay, let's put it back to 7.5. I think this is important for you guys to understand, is how much power it consumes. So right now we're sitting at 19.4, 19.5 watts. Okay, let's turn this down to 3.3. I'll let that settle. It's probably going to drop. So let's do the other channel while we're waiting. You've got to be careful here. You don't want to ground these out. Even though they're pretty much at zero potential, there's no signal on the speakers. And if it did ground out, I don't think it would do any damage, but I just don't want to risk anything. So we're at 5.2 on this one, 5.3. Let's turn this one down as well. To 3.3. Oops, too far. Wow, is that ever touchy? Okay, let's go back up again. You've got a dirty pot here. Okay, I'll leave it at 3.5. Let's check the first channel again. .1. I'm happy with that. This one, 3.7. I'm going to turn this one down a little bit more. Right there. We'll leave it at 3.1. Its power consumption has dropped to 18.3 watts or thereabouts. So your bias adjustment does consume some current. The more current you draw through the output devices, the more wattage it dissipates. So it's going to be a fairly cool running amplifier with 18 watts. It's going to be very cool. And when it's sitting at idle, it's a good amplifier because it's going to consume a low standby. Be good for listening to all day. Okay, so let's do a power test. Alright, so let's get on with this power test. So I got a 1000 hertz tone going in, 8 ohm load coming out, and scope both channels. Let's start turning it up. Okay, we got clipping in the top. Clipping on the bottom channel before the top channel. It's not. Let's see here. Right about there. Well, that's not. About there is balanced. And we have on the left channel, the top one, 24.45 volts RMS. Balance is correct. Okay, bass and treble tones are centered. We'll let this go for a while and we'll see what comes out of it. We're drawing 307 watts. Just let this warm up for a bit. So it's only been on full power for maybe a minute and a half, and this heat sink's getting quite hot already. So we're going to turn it down, so we don't need to break anything here. So let's, I just want to measure the other channel. Let me reconfigure my voltmeter. Okay, going up. I'm going to take the right channel to clipping. Right about there. Right there. I got 24.9 volts RMS. Touch higher, but I think that might be just my error in setting the level. So we do have a bit of a discrepancy between left and right. You can see overlaying them, there's quite a bit of difference between the two. Okay, let's do a square wave. Okay, 1000 hertz square wave. Oh wow. What kind of filtering do we have on here? What is that? Oh, there we go. It's this loudness button here. This. Okay, so that is supposedly a flat square wave. That's bass cut. Bass boost, treble cut, treble boost, volume control, or loudness I should say. That's our loudness, that's the effect it has. It's odd. It's almost like you have to tweak the controls to get it flat. It's a mute. It's a high cut. I'm not sure what that does. Okay, let's go up in frequency. 2. $17 kilohertz. It's actually doing not too bad. 17 kilohertz. That is 30 kilohertz. It's doing okay. A little bit of difference between the two channels, as you can see here. They're not matched perfectly. Yikes, that's hot. Okay, time to shut this down. Before I wrap this up and send it back to the owner, I want to check the phono stages. Now I'm feeding it a 10 millivolt signal at 440 hertz. Now, when I was doing bench testing, or testing this on my listening desk, I was getting noise from one of these phono, I can't remember if it was moving magnet or moving coil. It's getting noise which sounded like cell tower noise, but it actually was coming from my Wi-Fi router, and it was going into the circuit and it was making noise, and you could only hear it when you had it cranked full volume. So let's try this out here. We have let's see, phono. Plugging it in helps, as always. So I did listen to this for the last couple weeks after I closed off the video, And so I'm going to insert this clip back in the video before it's going to be kind of like a time warp thing. But it sounds pretty good. It worked flawlessly, so it's great. Here's our tone. Moving magnet, moving coil. Shut this off. Okay, there's noise from. Okay, let's try this without power here. Shut that off. Now I'm getting a different noise. It's very susceptible to stray interference. It's moving coil. Let's try moving magnet. Moving magnet's a lot less sensitive, I think. So let's go back and try our tone. Okay, let's go down in frequency. And as I go down, the amplitude comes up. That's the RII equalization curve. Down to 140 hertz. It's at 50 hertz. Yeah. It's all working normally. I just wanted to confirm it was working. And it is. Here's a look at the parts that went into it. A couple of filter cans. 6800, 63 volts. They tested down half their value. Power switch. 2 dead lamps. A couple of orange Elna caps. These aren't bad. I just replace these out of habit anyways because they will go bad eventually. Just replace them with a couple of film caps, and then a 10 nanofarad cross line cap. This one's not XY rated, so I changed it up for an XY rated cap. Well, there it is. It's done. What do I say about this one? Probably the same thing I said about the A60. The A80 is the same thing, except you get more power. Kind of a disappointment from Sansui. If you come across one of these, would you buy it? I'd probably pass unless it was sub $50. Even then, once you get it, you have to go through it and make sure it's all working, make sure it's got a good power switch. It's not going to burn your place down. That said, these are great sounding little amplifiers, but I wouldn't get one of these as my main driver for listening. I would get something a little higher end. This thing, well, it's okay. It's got its problems. One of the problems I was kind of alarmed by was how quickly the heatsink got hot on doing that little bit of power testing there for a minute and a half, and it got really hot. So which tells me that either, you know, it wasn't designed for large power, or either they cut back on the heat sinking. But hey, it is what it is. So I'm going to end this one here. Thanks for watching, and take care. We'll see you on the next one. Got lots of stuff coming up, so stay tuned.